can only be accessed with new technology. It's the future of space exploration, and it's next on Real World. Next-generation plans are well underway in NASA's mission to explore the universe. Constellation, a multi-spacecraft program that includes the Ares rockets, the Orion capsule, and the Altair lander, is currently in prototype and test stage. The Constellation program will take us to the International Space Station, the Moon, Mars, and beyond. The Ares 1 rocket, designed to send astronauts into space, is an inline two-stage rocket configuration, topped with the Orion crew vehicle and the most advanced launch abort system ever developed. The Ares 1 is coming together as a prototype, called the Ares 1X, which is nearing flight readiness. The crew vehicle and the launch abort system for the 1X were designed and built at NASA's Langley Research Center in Hampton, Virginia.
This is the crew module that has been built for the Ares 1X test flight. This has been designed and built here at Langley over the past 2 years.
Jonathan Cruz is the 1X crew module and launch abort system deputy project manager.
The primary purpose of this is to have the shape for the aerodynamics and the mass for the weight of the vehicle, and the sensors capture all of the environmental data.
The sensors built into the prototype will provide data on a number of crucial aspects of test flights.
We can figure out what the pressure, the temperature, the accelerations are of this vehicle during flight. And all that information will help us develop the actual vehicle that the crew will ride in.
NASA engineers had to build the prototype capsule to look just like the design of the final version of the Orion capsule.
We were given an Ares 1 design 2 years ago, and we have been building this very exactly and precisely to that. And to ensure it, we had little lasers that measure dimensions.
NASA engineers had the shape and size perfect, but had to make sure that the weight was right also. For a more simplistic object, you can calculate center of gravity using this formula, where W equals weight and X the location of the weight. But working with the Ares 1X was more complicated than that.
We had load cells during lifts where we would set it down at several points, weigh that and figure out center of gravity, because not only just the overall weight, but how that weight's distributed is very important.
In building the prototype so specifically, NASA is ensuring the final version will be safe and stable in flight when astronauts begin traveling into orbit and beyond. With that safety theme in mind, NASA has developed a system that will take the crew out of harm's way if the launch goes wrong.
Behind me is our launch abort system simulator, and it fits on top of the crew module that we just saw. The nozzles direct the force from the rocket that's built inside this launch abort system, the real one, and would pull the crew module away from the rest of the launch vehicle. Acceleration is on the order of 20 Gs or 20 times Earth's gravity, so it's a very powerful force to pull it away if there were a problem with the rocket.
Gravity is the force of attraction, or pull between two objects. It is this force that keeps us from floating off the planet's surface. 1 G is 1 times the force of gravity. Roller coaster rides create forces up to 4 Gs for a brief period of time. That means you feel 4 times heavier than normal. This is because of acceleration. Acceleration is the change in velocity over time. Velocity has 2 parts, speed and direction. So an object can accelerate by increasing speed, decreasing speed, or changing direction. As the roller coaster speeds up, slows down, and changes direction, it is accelerating. The people on the roller coaster are experiencing more or less force on their bodies than normal. The acceleration on the launch abort system will create forces 5 times more than you'd feel on a roller coaster.
When separated, the launch abort system then removes itself from the crew module. The crew module has parachutes built into it that open up and allow the crew to safely float down to Earth, similar as they would if they were returning from a normal space mission. For this particular flight, we're loading on a C-5 cargo craft. We fly that down to Kennedy. We assemble the entire rocket in the vehicle assembly building.
During the Ares 1X test launch, the rocket will climb about 40 kilometers up during a 2-minute powered flight, culminating with the separation of the first stage from the rocket.
From that launch, we collect the 2 minutes of powered flight data, and all of that will be used to compare to our analysis tools to see with the real flight data versus that. We can use that in continued development, and the plans are by 2015 to have crew in this being launched into orbit on the final vehicle.
NASA has high hopes for the Ares 1 rocket and all of the components of Constellation.
Everything is based on math, so it's kind of neat seeing how numbers on paper come to something like this that is real exciting and is going to fly into space.
You can keep track of the progress at www.nasa.gov.